Good morning. Today we will see few problems, previous year problems, gate problems in signals and system. A continuous time, linear time invariant, that is LTI system, is described by d square y of t by dt square plus 4 dy of t by dt plus 3y of t, which is equal to 2 into dx of t by dt plus 4x of t. Assuming zero initial condition. So what we have to assume? Zero initial condition. The response y of t of the above system for the input. So the input is given as x of t is equal to e power minus 2t into u of t. So that is given by. So we have to find the solution from this. Now what is the question given here? That is d square y of t by dt square plus 4 dy of t by dt plus 3y of t is equal to 2 into dx of t by dt plus 4x of t. This is the question given. Now what we have to do? Let us take Laplace transform. So what we have to do is, first we have to take Laplace transform and we have to assume zero initial condition. So what they have given is zero initial condition. So we have to assume zero initial condition. Now s square, take Laplace transform for this. So s square y of s plus 4 s into, so here we have s into y of s plus 3 y of s, which is equal to 2 into, so here we have dx of t by dt, so that is equal to s into x of s plus 4 into x of s. Now let us take y of s common here. So we can write this as y of s into s square plus, here we have 4s plus 3, which is equal to, and here we can take this x of s. So we can write this as x of s. Take this s of s as common, 2s plus 4. Now we can write this as y of s by x of s is equal to, what is y of s by x of s? So we will get this as 2s plus 4 divided by, here we have s square plus 4s plus 3. So what we did is, we have taken Laplace transform for this. Now what we have to do? Now what we have to do is, now since what is the question given, x of t is equal to, here input is given as x of t, which is equal to, so here we have e power minus 2t into u of t. So this is there in the question. So they have given input x of t is equal to e power minus 2t into u of t. Now let us take Laplace transform for this also. So what is the Laplace transform? So we'll get x of s is equal to 1 divided by e power 2t. So here we have 2t. So we can write this as s plus 2. Now y of s, what is our y of s, which is equal to, so we got this y of s is equal to 2s plus 4 divided by s square plus 4s plus 3. Here we have by x of s, so we can write this as x of s here. Previously we have got this y of s by x of s is equal to this expression. Now we can write this y of s is equal to, now take this x of s into multiplication. So which is equal to 2s plus 4 into by s square plus 4s plus 3 into, now what is this x of s? Now here we have x of s is 1 by s plus 2. So here we have x of s is equal to 1 by s plus 2. Now we can take this 2 as common. So we will get s plus 2 divided by s square plus 4s plus 3 into 1 by s plus 2. Now what happens is s plus 2 cancels. So therefore we will get 2 by s square. Now let us take this as s plus 1 into s plus 3 in s plus 3. Therefore, and already in the previous problem, the previous video, I said how to write this, or if you want we can write this also, that is 2 by, we have this s plus 1 into s plus 3. You know how to write this plus 1 and 3 because we have 4. So we have to take 3 1. So these are basics which you know very well. So which is equal to, we can write this as a by s plus 1 plus b by s plus 3. So if you substitute s minus 1, we will get a is equal to 1. Likewise, if you substitute s is equal to minus 3, because here we have plus 3, so minus 3 will get b is equal to minus 1. Therefore we can write this as y of s will be equal to, so that is 1 by s plus 1 minus 1 by s plus 3. So that's it, because if you take this here, we will get 2 is equal to s plus 1 in 2 is equal to a into s plus 3 plus b into s plus 1. So in order to make a b as 0, we have to put b is s equal to minus 1. If you want to make a as 0, then we have to put s is equal to minus 3, so that you will get a1 b is equal to minus 1. So we will get this expression. Therefore what is y of s? So this is our y of s. Now what we have to do is take inverse Laplace transform for this. If you take inverse Laplace transform for this, what we will get? That is y of t. This s will become t, which is equal to, and here we have s plus 1. So we can write this as e power minus t, because here we don't have any number, minus e power, here we have 3. So minus 3t into u of t. So this is the final answer, that is y of t is equal to e power minus 3 minus e power minus 3t into u of t. So in the given problem, the solution for this is e power minus 3 minus e power 3t into u of t. This is the solution for this. Now let us move on to the next problem. So here given f of t is equal to Laplace inverse, it is visible, Laplace inverse of 3s plus 1 by s cube plus 4s square plus k minus 3 into s. If limit t tends to infinity, f of t will be equal to 1. Then the value of k. Now what we have to find is, just we have to find the value of k. Here listen, what is given here? F of t, which is equal to Laplace inverse of 3s plus 1 divided by s cube plus 4s square plus k minus 3 into s. This is what they have given in the question. And also here we have limit t tends to infinity for f of t is equal to 1. So if f of t, you take the Laplace transform, what we will get? That is f of s. So f of s will be equal to, so for this we can write this as 3 into s plus 1 divided by, let us take this s as common, so we can write this as s square plus 4s plus k minus 3. That's it. Now we know that if here in the question they are given limit t tends to infinity, f of t will be equal to 1. Now by final value theorem, so by final value theorem, limit t tends to infinity, we can write f of t will be is equal to limit, if t is equal to infinity, we will get s is equal to 0. And we know we should have to write this as s into f of s, which will be equal to 1. So if t is equal to infinity, we will get s0, and if s is equal to infinity, we will get t is equal. These are basics which you know very well. So what we have to do is, here we have limit s tends to 0, s into, what is this f of s? So we know that f of s, that is 3 into s plus 1 divided by s into s square plus 4s plus k minus 3, which is equal to 1. So here s cancels. So what happens here? If you substitute 0 for this s everything, therefore we will get 1 by k minus 3 is equal to 1. Therefore from this we can get k is equal to 4. So what we did is, just we have taken the Laplace transform for this, and we have to substitute s equal to, why we are substituting here? Because they have given if limit t tends to infinity, f of t is equal to 1. So if t tends to infinity, in the question we have t tends to infinity, so here we have s tends to 0 and s into f of s. This s is cancelled, so that we will get k is equal to 4. So the option is D. Now let us move on to the next problem. If f of s is equal to Laplace transform of f of t, which is equal to 2 into s plus 1 by s square plus 4s plus 7, then the initial and final values of f of t are respectively. So these are the options given here. Now we have to find the answer for this. So what is given here? Laplace of f of t will be equal to 2 into s plus 1 divided by s square plus 4s plus 7. Now according to initial value theorem, it is given by limit. We know if it is initial value theorem, t will be tends to 0, so f of t will be equal to, here limit s tends to infinity, because previously we had t is equal to infinity, so we had s is equal to 0. For initial value theorem, t will be 0 and s tends to 0, and here we have s into f of s, which is equal to limit, here s tends to infinity, so s into, what is our f of s? Here we have f of s as 2 into s plus 1 divided by s square plus 4s plus 7. Now f of 0 will be equal to limit, here we have s tends to infinity, so therefore we can write this as 2 into s square, because we have s here, 2 into s square. Let us take this s as common, so we can write this as 1 plus 1 by s divided by, and here take this s square as common, s square into, so we can write this as 1 plus 4 by s plus 7 by s square. So what we did is, just we have taken multiplied this s, so that we'll get 2 into s square. So we have taken this 2s square as common, and here we have taken s square as common. Now what will be our f of 0? Therefore f of 0 will be equal to 2 into, and here what we have substituted, s is equal to infinity. So what happens? 1 plus 0, and here this will be 1 plus 0 divided by 1 plus 0 plus 0, so that we will have, which is equal to 2. This is for initial value theorem. Now what will be our final value theorem? So final value theorem is given by limit. So what happens for t here? Here if it is initial value theorem, we will take time as 0. If it is final value theorem, then we have to take time as infinity. So f of t will be equal to, so if t tends to infinity, what happens to our s? Therefore limit s tends to 0, s into f of s. Now we have to substitute, which is equal to limit s tends to 0. Now what is our s into f of s? We know that f of s is given by 2 into s plus 1. So 2 into s plus 1 divided by s square plus 4s plus 7. Since s is equal to 0, what happens? So everything will be, f of infinity will be equal to 0, because if you substitute here 0, so everything will become 0 here. So f of final value theorem is, what is the question? They have given initial and final value theorem. So our initial value theorem is 2, so here we have 2, and our final value is 0, so final 0. The option is B. Now let us move on to the next problem. That is our fourth problem. A casual linear term invariant system has 0 initial conditions. So it has 0 initial condition and impulse response h of t. Its input is x of t. So what they have given is, its input is x of t. Then its output is y of t, or related through the linear constant coefficient differential equation. So here is the differential equation. Let another signal, we have g of t, and it is defined as this equation. If g of s, here we have g of t. If g of s is the Laplace transform of g of t, so if it is the Laplace transform of this g of t, then the number of poles. So we have to find only the number of poles here. So in the question they have given x of t will be our input of the casual system, and output is y of t. Y of t is the output of the casual system. So x of t is input, y of t is the output of a casual LTI, that is linear term invariant system. Now what we have to do is, and here they have given d square by, so let us take the Laplace transform for this equation, that is here we have d square by dt square. So we can write this as s square into y of s plus, here we have alpha, so alpha s into, here we can write this as y of s, then plus here we have alpha square into, here we have y of t, only y of t. So we can write this as y of s, which is equal to x of s. Now we can take this x square, y of s as common. So if you take this y of s as common, we can write this s square plus s alpha plus alpha square, which is equal to x of s. Now let us write the transfer function. So we know that the transfer function is given by output by input. Therefore h of s, which is equal to y of s, because y of t is our output, so y of s divided by our input is x of s, so it will be equal to, if you write this, we can write 1 divided by, here we have s square plus alpha s plus alpha square. Now what we have to find is, listen, what we have to find is g of t. So g of t is given by, in the question it is given as g of t is equal to alpha square in 0 to t h of tau into d tau plus dh of t by dt plus alpha h of t. So this is there in the question. Now what we have to do, we have to take the Laplace transform. Now let us take Laplace transform for this. So we can write g of s, which is equal to, here we have alpha square, and if you take the Laplace transform for this, we can write this as h of s by s, because here we have d tau, so h of s by s, plus we can write this as s into, here we have d tau, dh of t by h of s, so we can write this as h of s plus alpha into, here we have only h of t, so we can write this as h of s. Now what we can write the same expression as g of s, which is equal to, because we can take h of s as common, so alpha square by s plus alpha into h of s. So we can write this as, which is equal to alpha square plus s square plus alpha s divided by s into h of s. Now substitute the value of h of s, because previously we have found this h of s, so already we found this h of s here, so we have to substitute this value here. So here we have h of s, so we can substitute that value here. So we know that g of s is equal to, here we have alpha square plus s square plus alpha s by s into, what is our h of s, that is 1 by, here we have s square plus alpha s plus alpha square plus alpha s plus alpha square, isn't it? Now what happens, this two gets cancelled, therefore we have, which is equal to 1 divided by s, so g of s will be 1 by s, and therefore we have number of poles will be, number of poles for g of s. So here we have g of s equal to 1 by s, so we have only one pole, so number of poles is equal to 1, because here what they have asked in the question is, if g of s is the Laplace transform of g of t, then the number of poles of g of s, so number of poles will be equal to 1. Now let us move on to the next problem. Consider the differential equation dx by dt is equal to 10 minus 0.2x with initial condition x of 0 is equal to 1 and the response x of t for t greater than 0 is, and these are the options given. Now in the question they have given dx by dt, which is equal to 10 minus 0.2x. Now what we have to do, take Laplace transform for this. So x into x of s will minus, and here they have given x of t for t is greater than 0. So we can write this as x of 0, which is equal to, we can write this as 10 by s. Here we have 10. In the question they have given 10 by s. So here we have 10. So we can write this as 10 by s minus, here we have 0.2x, 0.2 x of s. So we can write this as s into x of s minus, so x of 0 will be greater than this 0. So let us take this as 1. So which is equal to 10 by s minus 0.2 x of s. Now what, take this x of s as so we can write this as yes. Now take this 0.2, that is plus 0.2 will be equal to 10 by s plus 1. Now we can write this x of s, which is equal to, now take this 10 divided by s into s plus 0.2. So 10 divided by s into s plus 0.2 plus 1 divided by s plus 0.2. So what we can do is, so already I said how to write this, that is 10 divided by s into s plus 0.2. So we can write this as a by s plus b by s plus 0.2. So if you take this, we can write this a 10 is equal to a into s plus 0.2 plus b into s. Now if you substitute here to make this s 0, so if you substitute the values, you will get a's and b values. So that value will be equal to 50. So we can write this directly, 50 by s minus 50 by s plus 0.2 plus 1 divided by s plus 0.2. Now what we have to do is we have to take the inverse Laplace transform for this. Now take the inverse Laplace transform for this. This is our x of s value. So let us, this x of s, if you take inverse Laplace transform, this x of s will become x of t, which will be equal to, here we have 50 by s, so we can write this as 50 u of t, and here we have minus 50 by s plus 0.2 plus 50 by s plus 0.2 will become minus 49 by, or else we can write that is 50 by s, here we have plus, here we have minus, so minus 49 by s plus 0.2. So we can write this as minus e power, that is here we have 49 e power 0.2 will be there. So minus 0.2 t into u of t. So this is our final answer, that is x of t is equal to, or we can write this as x of t is equal to, let us take this u of t as common. So if you take u of t as common, so 50 minus 49 e power minus 0.2 t into u of t. This is our final answer. So where is the option? 50 minus 49 into e power minus 0.2 t. So this is our final answer. Option C is the correct answer. Hope you understand this. If you like this, subscribe, share and support. We will meet soon in the next video and we will solve some other problems. Thank you.